Ed. Ed is going to talk about IPv6 meets large response from TLD server, which is essentially a follow-up to the question that we just had. Ed, the floor is yours.
Good morning, and thanks for the lead-in question, because this talk is pretty much centered on the large packet question. Where this work comes from is the question that's been hanging around this process for some time. There's been IPv6 fragmentation. There's been a kind of question out there. It's different from v4. Will this be an issue when the root KSK rolls over? Because we're going to start getting into some of the danger zones, we think. That was some of the fears out there. So basically, the number 1280 is a magic number to some folks about the size of packets out there in the DNS that might become fragmented. We're going to hit 1424 and at least one time in this. Why are we concerned about this? Unlike v4, v6 fragmentation is different. It's different. Different means chaos, basically. So it works a little bit differently. In v6, when you send a packet through the network, it gets fragmented at the source. If something in the middle doesn't like the packet, it sends back an error message saying, I can't handle this, come back with a smaller amount. The idea is that the source would then get that message and say, okay, let me retry my message at smaller fragmentation levels and I'll get through this just fine. The problem with DNS is it has amnesia. It forgets what it sent. So when that comes back, it's useless. I can't repeat what I said because I forgot what I had said and the message didn't tell me what it was. So we've been kind of concerned about that. The DNS community has been concerned about how fragmentation may affect, the v6 fragmentation may affect this. So that's kind of the genesis of what this little work is trying to be. What could the outcome be if there's problems here? If the DNSSEC key set does not get through to the queriers, the automatic update of DNSSEC trust anchors, or RC 5011, might have problems. As was explained earlier by Matt, that 5011's process requires us to put the new key signed by the old key out for 30 straight days. And if there's no disruption to that presence of that data, the other end assumes it's a good key. There's no confirmation in this protocol. However, if there's any kind of a glitch in there, people get scared and they stop trusting the new key and restart the process of trying to learn a new key. So we've been concerned about this. Will these fragments and fragments getting dropped cause problems for the automatic updates process? And so that was actually one of the early concerns in this task. In fact, at one time we considered going to a new algorithm, DNSSEC algorithm for assigning the root zone. We decided not to because there was more chance that someone wouldn't support the new algorithm than possibly fall to the large fragmentation issues out there. Can we test this? There's a couple ways to test it, but there was one particular test that I had in mind, and I've been running for some time, and actually something that I've been watching for a couple of years going back in history of DNSSEC operations. At the TLD level, there are a lot of TLDs that have really large key sets out there. Looking at recently that I can get key sets ranging from as low as 571 bytes in a response, which is small, I don't care about those. The largest one is 3,319 bytes right now. There's some TLD out there sending out a key set that's that big consistently. It's not just one, there's just not one that does this. We have about 115 cases where we're above the 1280 magic number that we're concerned about. That's like 7.5 to 10% of all of the TLDs out there. So it's a noticeable chunk of the TLDs out there are running in what we consider to be a zone of concern. There are 80 of them that are over 1,500 bytes, which definitely should be ones we're looking at. But the strange thing in this, and this has bugged me for all the years that I've been looking at this, no one's complaining about this. We're concerned about this v6 fragmentation issue, but no one's complaining that they can't get the TLD server, TLD keys out there. So maybe the fear of v6 is a bit misplaced. So basically, I'm going to look at TLD operators, but it's very tempting when you do this to start thinking that I'm evaluating a TLD operator. So I want to be clear that I'm not. This is a test about whether or not I can receive data from their servers. There are many reasons why I would not get a response from someone who's no fault of the other end. For example, my query might not get there. They may not answer, which would be what would be a sign of bad operations. But most likely, in this case, the answer would not get back to me because something in the middle of the network is dropping these packets on the floor. So doing this, it's a very difficult kind of test to do, to be neutral in terms of what operators are doing and evaluating the protocol. I'm after the protocol's effects, not the operations effects in this test, because there are many different ways you can slice this data. So things I have in mind here, when I look at particular server, I look at things in two different ways. I look at the TLD, looking at all the servers together, union them together, and I look at the servers themselves. And there are different reasons why I may not get a response back. Maintenance is one thing, DDoS mitigation changes things, and sometimes mid-network peering fails, and I've seen evidence of all of this. So what I'm presenting is not a measure of operators. I don't want people to think I'm measuring operators. I'm trying to measure what I see at the receiver in the protocol. So the test is basically there to measure what I receive. And if you've ever done any kind of a test where the object is whether I get an answer or not, it's very tricky. If I get answers back that are wrong, I know I've gotten an answer. I know that the answer is wrong. I can figure that out. But when something's missing, you want to pin down why is it missing. So this test first just make sure I get something back. And what I record in here, I don't have this on the slides, I record the size of the key set that's coming back to see if I can see a bubble. I expected in this test that there would be a bubble of sizes where I see a lot of failures. And that's what I was looking for in this. Now, so to do this kind of testing, I test once a day. I go to all the TLD servers out there. And I also have been expanding the locations from where I'm looking, because as I look further and further, you see more interesting effects. So the setup is I take the root zone every day. I look at the glue records that are registered by the TLDs, meaning the TLD tells IANA, or PTI, here are my servers, lose these addresses. And I mention that because later on that's actually something that affects one of the results. I ask for the SOA record to see if the server is actually running, because not all the servers are out there running all the time. I then ask for the record set, the DNS key record set over UDP and TCP. I look from a couple of locations right now. I have some hosted VMs that are hosted by a professional organization. They're in hosted level connectivity places. They probably have better bandwidth. They may have some better features. And also, I'm running out of a generic home setup because that's just probably the dirtiest place to run the test. So the first part of this is, why do I hear no complaints? And so I slice the data looking TLD by TLD. And that means I ask all the servers for that TLD, and if I get back a response, I consider that to be a success. I get something out. So looking at, from 4 of my hosted sites, I look over, these are a 10-day period, and I put all the dates down there just to give you an idea of what we're looking at. And you see that in V6, which is in the black there, I have 1 drop on TCP and 1 drop on UDP across the board. And I have nothing in V4 that drops out. This is very boring. As a researcher, I hated seeing this because there's nothing to look at there. I'll just mention that the 1 dropout is the same TLD, and I'll get back to that later. Now, fortunately, I have some more interesting stuff as a researcher, and less fortunate if you're an operator. If I go to another site, I see that there's some more variation in the results. And I go to the house site, and I see a bit more there too. But in this case, and I'm going to speed up a little bit because I'm to get to all the material. I still see there's 1 on TCP that fails for the most part. I see a second one at the house, and then a few other spurious ideas. The lone CCTLD that's failing out there, I discovered, because I digged into this one case, they didn't register all their name servers with PTI or IANA. They actually have a running V6 server out there, and if you have an aggressive name server that does a very aggressive look at trying to find the data, they will get this data. It's available through authoritative servers. It's not in the set of data that I have. So I would, this calls out, TLDs need to make sure they have proper things registered with IANA. This residential, the second dropout was a consistent answer. I haven't dug in to see what that was. And finally, in the UDP case, where I found a bunch of dropouts, it was kind of curious. There was a consistent set of TLDs in that area, and they seemed to be related to each other. Now, I have a policy of not naming names, so I won't go further than that, but their names were kind of related to each other, which made me think that there was more of a connection, and we're trying to figure out if there's a story behind that. So to move on to 1 level deeper, that was TLD by TLD, and the reason why we see no complaints is for the most part, you can always get the answers over TCP or UDP, so I recommend TCP ought to be available everywhere. So what about server by server? And this is a look averaging over a couple of days, and I will skip ahead to these more detailed slides to show if you care about what my averages mean, these are the data. But this slide captures all the points I want to make. I have servers up on top, and the top graph is, the top chart is V6, the bottom is V4 for reference. What is considered bad is I don't get back an answer from that particular IP address, not that TLD. No SOA means the server is probably just not alive for when it's maintenance or it's just not properly registered. And you can see in many cases, like the first one, Amsterdam, most of the reasons why I don't get a result is because the server is not answering. Below that I have, do they fail only on TCP, do they fail only on UDP, or do they fail on both down there? For example, the one TLD that didn't respond to me is always in the no SOA category. That's why there are zeros in some of these. But you get an idea that there's, for TCP, things are pretty good out there. There's almost nothing significant. In UDP, a little bit of variation across the board. And if you look at the residential one, you see a lot bigger numbers. In fact, the residential failures equal basically all the 5 VMs together. In V4 down below, just as to give you an idea what we're against, the residential network is actually right in the middle of the VMs. In V4, it seems like, V4 is obviously more mature. It seems to be running better to the house than it would be to some of the VMs. And again, I should say I'm generalizing from one location, but it just kind of hints that way. So if I move on to my what does this mean slides. So what's in, the things I bring out is local conditions matter in V6. I don't think V6 is significant, is as common across the internet right now. So there may be some more differences in particularly where you are in getting this. For the most part, there's no significant pattern of failure between the TLDs. The residential host has a few errors here and there, which I'll come to in a second, I believe. So what does it mean for the KSK rollover? This is back to a KSK rollover talk initially. What I'm anticipating now, and this goes to what we see about breakage, I'm anticipating that there may be sporadic reports of breakage for folks who have network challenges in V6. I don't necessarily see widespread outages. I don't see a pattern. I don't see the ISPs would be here. As Matt said, some of the major commercial providers already are on top of this, and we don't think that they're going to have a problem with this, with the change of the KSK key. But we may get hobbyists, is a word I would use to describe some of the people here. People who are doing this at their house, they may see problems. And judging from work I've done in the past, they may pipe up saying that there are some issues here and there. I'm kind of anticipating that based on people running things in their house. So, and also, if a DNS service provider has poor connectivity, that may be another source of issues out there. And as far as like the Bangalore case, I'm judging Bangalore as being in a lesser network connectivity based on just my access of the machine seems to be slow too. So what does it mean for V6 and DNS? I don't think the large responses are a primary problem. I think there may be issues with just getting through to places. The dropouts are probably related to other issues, more so than fragmentation and retransmission. Yeah, when I was looking at this, I could probably do better work with this using the RIPE Atlas in this case, because that, I think it's what's better suited for than some of the work I've been doing. So with that, we'll leave Jeff to come in and ask the question, which I was guessing would be coming. And anyone else who wants to ask a question, anyone other than Jeff that wants to ask a question, please.
So you're testing from one kind of test point against all servers. For the same route work, we've been using a Google ad campaign, and we've been doing around 1.5 million ads a day for over 9 months. And we're testing almost every resolver that services eyeballs against the routes, as well as against our servers. The root server behavior is disappointing, and the only reason why it won't be a problem is you've got 13 of them in dual stack, because every single one of them don't do it well in certain aspects. UDP packet loss. If you send out a 1280 octet packet, you can expect a relatively low failure rate. If you fragment it, so in other words, if you send out a large packet, you're okay. If you send out a fragmented large packet, expect 20% packet drop from authoritatives to recursives. So large UDP in V6 is working badly with fragmentation. TCP will save you. No, it won't. 17% of resolvers, when you send them a truncated answer, will not send back in TCP. That affects 6% of users. So TCP won't help. Does IPv6 work against the roots? C, D, E, I and K. Yes. H and the others? No. B, G and J truncate the UDP answer in v4, don't know why, but then handle the v6 stuff badly. So there's a litany of little problems out there in all of these root servers. None of them do it perfectly. And a lot of it is an engineering trade-off, but it's all different trade-offs that each of them make. As long as a resolver is willing to try multiple letters and multiple techniques, they will get big answers, no problem. If they latch onto asking any one, the pathologies of those behaviours will guarantee they will never get the large answer. So you've got to try both protocols and more than one server letter, and you're okay. If you're cemented against A in v4, you may or may not be okay. If you do it in v6, you probably aren't. So it's not quite as optimistic as that, Ed, and a lot of this has to do with the fact that v6 presents problems that the answers that the root servers have taken have been variously implemented, and all of them face some kind of problem in trying to get the large answer back. Thanks.
Thanks. Yeah, between Jeff's questions and what I've been looking at, what comes out is that declaring a failure on the internet is very hard. I'm measuring one way, Jeff's measurements are a bit different. It's true, in both cases, there are servers that don't answer. And the question is whether a server not answering matters or not. Fortunately, I guess one of the things unfortunate about DNS is that it's a very resilient protocol. It gets over problems and you don't even know you have them. I've done a lot of other work where I've looked at how names are resolved, and it's amazing that if you take there are many well-written DNS recursive servers out there that are incredibly aggressive at finding an answer. And so long as they have the chance to get there, they will get the answer, even though it may break the protocol to get it. They actually do get answers. I'm surprised a couple times. So in terms of trying to assess, going back to the question that was asked to Matt at the end, was what percentage of the internet will break? It's really hard because we have breakage all over the place. We overcome it in most places. We can have a strategy for make sure you can do this. So when I'm saying use TCP and we get through there, that puts you in the best position, you as an operator out there. If your name server code does the most aggressive thing, which is try the letters, try this, it will get through. It's possible that the name server code is not that aggressive, in which case it may fall apart. But it's hard for someone out there to, the DNS, it's not regulated. No one regulates DNS. You run what you want on the network. And if you run code out there that's not going to be that aggressive in getting the answer, you will not get some of these answers. But from what we're seeing is it's possible to get the data through. And if you have code out there, and the code that I'm talking about is very commonplace, the really good aggressive code has been around for a long time. I try not to name names and all that, but a lot of the code out there that's available, public source, freeware code out there, and commercial ones too, are aggressive, and they won't see the issues. It's still possible that you will find, if you look for why this server doesn't come to me, we got an issue. For example, one of the results was in my house, I can't see one root server over v6. That's for my house. But the VMs see it, and other people see it. It's a localized issue. There's a peering problem between my ISP and apparently whoever's running the root server out there. Not the root server's problem, it's an intermediate peering problem. So that's what I say. I think that the data is available, and if you're aggressive, you can find it.
So your comment about aggressive code will get through. Apropos of the remarks that I made this morning, it gives me a picture of sort of systems that are fighting with each other. So you get a fair amount of waste and expense in the middle, sort of like having an air conditioner that's blowing too much, so you bring a heater in, and you get the picture. Appreciate not wanting to name names, and there's no reason to do it here, but the point that I was making earlier is that if we could bring these policies, I don't know what word you want to use, but in some sense these are policies within each of these systems, into perspective and show how they interact with each other, we may be able to get, not by regulation or enforcement or police, but at least by sort of clearer picture of what's happening, perhaps some convergence toward a more efficient and more effective system.
Yeah, yeah. You mentioned competing systems out there. I've known over a longer period of time of history and research of this. A lot of the operators of protocols defend themselves against the other protocols, and that sometimes defense is they counteract. Yeah, I don't know where to lead with this. I think it's a good idea if we have expectations of performance, or not speed performance, but functional performance would start helping in an architectural look at this.
I need to close the line after the next question.
Hi, Greg Choules, 3 UK. We're a mobile operator, so essentially large recursive servers. In some testing that we did earlier this year, for whatever reason, whether it's our own routers, whether it's our upstream ISPs routers, whatever, we tend to get a lot of fragmentation and discards. And so pragmatically what we've done is just set limited UDP size to 1472, and just experimentally that's the number that just seems to work for us. We don't get packet loss through that, and we don't need to get retries. So it's going to force a bit of TCP a bit more often, but it's just the number that seems to give UDP the best chance of working before it needs to switch to TCP.
Yeah, well, thanks. That's actually the kind of data that would be great to collect, and we haven't had a systematic way to reach folks that are doing that. So but it's great to have those numbers out there, that the experience is documented. So.
Thank you. Thank you, Ed.